Okay, here's another previous exam problem on variance for annuities. We are given that y is the present value random variable for a 30-year temporary life annuity of 1 payable at the beginning of the year while x survives. Before I go any farther, just to clarify, I talked about this a little bit in another video, but I'm going to use this double line underneath the A to indicate that this is the true present value of this annuity if we knew exactly their mortality. In other words, the expected value of this what we're estimating based on our survival probabilities is this 30-year temporary annuity due on X that you're used to seeing like this. Okay? We want to find the second moment of Y. We want to find the second moment of this present value random variable for this annuity. So, I know that the variance of a random variable is its second moment minus the expected value of the random variable squared. So we're looking for the second moment. I know that that's going to be the variance of our random variable plus the expected value of our random variable squared. Okay, so let's find those two things. First, let's find the variance. Let's just come up with a formula for it, and then we'll see what pieces we need and see if we can find those based on the other information that we're given. We're given that the annual effective interest rate is 5%, that the probability that an X-year-old survives 30 years is 0.7, that the second moment of a 30-year term insurance on X is 0.0694, the actuarial present value of a 30-year term insurance on X is 0.1443. And again, we're looking for the second moment of this annuity. So, the variance of this annuity, I'm going to rewrite the annuity as 1 minus the insurance, 1 minus the corresponding insurance over the appropriate interest rate, which is D here because we're working with an annuity too. I'm going to break this up. This is the same thing as the variance of 1 over D minus the insurance over D. Okay, the variance of this is 0. I'm going to pull out the negative 1 over D and square it. And we're left with the variance of the insurance. Okay, so we're going to have the variance of the insurance over D squared. This is a 30-year term insurance that pays at the end of the year of death. Okay, over D squared. I know that the variance of a random variable is its second moment minus its expected value squared. So this is going to be the second moment of our endowment insurance minus its expected value. We know the expected value of the true present value of this insurance is going to be the actuarial present value of the insurance. Okay, squared. Looks more clear with parentheses maybe. all over D squared. Okay, so I need to find the actuarial present value of the 30-year endowment insurance, and I also need to find the second moment of that insurance. And D, of course, I can get from the annual effective interest rate. So setting that aside, I'm going to try to find these two pieces. Okay, I know that the, let's start with the actuarial present value of the 30-year endowment insurance on X, payable at the end of the year of death. I know that the endowment insurance is the term insurance plus a pure endowment, however you want to write it, 30EX, which is 30PX, the probability that you live 30 years, V30, discounted back for 30 years, because this pure endowment is a payment of 1, so the benefit is 1 here for certain, if you live to that point, and then we're discounting it back to the present. So we're given the term insurance is 0.1443, and the 30PX, the 30 is going to be, well, it's 0.7 times 1.05 to the negative 30, and that gives us 0.3063. Okay, now how about the second moment of that endowment insurance? I sort of took a wild guess here that the same relationship would hold for a second moment, and it does. So that's nice. So the second moment of the endowment insurance is the second moment of the term insurance plus the second moment of the pure endowment insurance. So write that out. I guess. Right? This is the same as the 30EX. We're given the second moment of the term insurance. That was nice. This is 0.0694. And then, let's write this out, 0.0694. Now, for the second moment of the pure endowment insurance, that's going to be calculated the same way we calculated the actuarial present value of the pure endowment insurance, except we double at twice the force of interest. So this is still 30PX, but now it's going to be, yes, V30 at 2 delta. So you can use I to solve for delta, and then discount with interest at twice delta. So this is going to be e to the negative, I got, I got 0.09758 for delta. But anyway, for 2 delta, I'm sorry. Anyway, this is going to be e to the negative 2 delta times 30. Okay, second moment of the endowment insurance equals the second moment of the corresponding term insurance plus the second moment of the corresponding pure endowment insurance. And I got 0.1069 for that. Okay. So the only thing left then, we were trying to find the variance of y. We said it was the second moment of the endowment insurance minus the actuarial present value of the endowment insurance, or in other words, the expected value of the true present value of this endowment insurance squared over D squared, discount rate squared. So we said that the second moment was 0.1069, that the actuarial present value was 0.3062, 2 squared over D squared, 0.0476 squared, and I got 5.767117, although I'll stick to 4 decimal places. Okay, we're trying to find the second moment. We said before that that was the variance plus the expected value squared, which is going to be the variance plus the actuarial present value of our annuity squared. So we have the variance, now we need the actuarial present value of this annuity. And we know that that's going to be 1 minus the corresponding insurance. So we have this endowment insurance, which we said was 0.3062 over D, and I got, when I added the variance to, this is the expected value of Y. When I added the variance to the expected value of Y, quantity squared, I got 218.007. This is your second moment, which is our answer. All right, maybe that cleared some stuff up for you. Hope so. Hope it was helpful, and happy studying.